Students, today we are going to be learning a very interesting topic. When I was taught about this the first time, I was very confused about this. But later, when I discovered why things happen the way they do, then everything made a lot of sense to me. And then I got to learn that mathematics and physics. When you go deep down into that, you just should not remember stuff. You just should not start to memorize stuff. You should try to find an answer for everything, like why things are happening the way they are. And if your teacher cannot provide answers for that, then uh, you probably don't have to question your perception about the subject. You just need to change your teacher. So what I'm saying is, if there's a vector, let's say v vector, and with a straight line, it creates an angle theta. So you know that if this situation occurs, you can decompose the vector in two components, two perpendicular components alongside this angle. The angle theta, the side that would be attached to the angle theta, that one would be called v vector cos theta. And the other one will be called v vector sin theta. Okay. The thing is, why is that? Why does this happen this way? Like, first of all, why do cos and sin components even exist here? And secondly, why is cos on this direction and not on this direction? And why is sine on this direction and not on this direction? Today I'm going to teach you that. So let's get into it. Let's say we have a coordinate system here. This is our x-axis and this is our y-axis, and this point is our origin point. And let's say we have a straight line here. Basically, you can think of this as a vector pointing towards this direction, and this creates angle theta with our x-axis. Now let's draw a perpendicular from the tip of the vector to the x-axis, and let's call these two points A and B. So we got a rectangular triangle ABO, of which angle ABO is 90 degrees, angle AOB is theta, and angle OAB is 90 minus theta. Okay. Now we are going to be applying a bit of trigonometry here. So from the perspective of this angle theta, what would be the output of the cos operator? Cos theta would be, for any triangle, cos theta is the base from the perspective of the angle we are talking about, that is, which in this case is OB over AO. Now, since AO is the length of this line, and this line is here is it's indicating a vector here, so, and we are naming this vector V. So instead of writing down AO here, we are going to write down V vector. Okay. Now from this equation we can get that OB equals V vector cos theta. Okay. So when I compose these two, this vector into these two components, you can see that the component, alongside our angle theta, which in this case is OB, is according to this equation, it's going to be V vector cos theta. And what about this other component? Let's try to find that out. Uh, what would be sine theta in this triangle? What does sine of theta do? Is it gives us the ratio of height over the hypotenuse height, that is from, again, from the perspective of the angle that we're talking about. Height of any triangle from the perspective of any angle is the side exactly opposite to the angle. In this case, it is AB, and you would have AB over OA, but since OA is denoting the vector V here, so just write that down here. So from this relation, what you get is AB is V vector sine theta. Okay, so this what does this mean? This means that this line here AB, it's gonna be V vector not dollar theta, V vector sine theta. Okay. Now you might be asking that, sir, according to like what I have calculated here, this line should be V vector sine theta, and but when we're trying to decompose a vector, we take the other component of the vector, which is not alongside of the angle cos, sorry, theta. That one is sine theta. So like this doesn't make any sense to you, right? So the thing is that let's name this vector, these 2 points OM. I mean, we have origin here. Let's name this point M. So this is OM, and let's say this is a vector as well. And this one V vector sine theta, that is AB. Both of these vectors are parallel to each other, and they even have the same length. And when a vector when the arrow that is representing a vector, when 2 arrows like that have same length, what does that mean is that they have the same magnitude, and in this case they are also pointing towards the same direction. That means these two vectors are they have same magnitude, and they are pointing towards the same direction. This means that this vector AB and this vector OM and BA, both of them are the same vector. Even though they might look a bit different on this 2D plane, but since they have the same magnitude and they are pointing towards the same direction, that concludes that these two vectors have to be equal. And since these two vectors are equal, and vector BA is V vector sine theta, so this one OM, this one too will be V vector sine theta. Okay, so now you understand why when you decompose a vector, the component alongside an angle theta is called the cos component, and the other component is called the sine component. Okay, I don't think there should be any doubts regarding this topic anymore. But if you still think that I should make a few things a bit more clear about for you, you can definitely let me know about that in the comments, and I'll make sure to clear that doubt out. Okay, and since then, and until then, keep learning. Bye.